Okay, today your lesson is on classifying triangles. So triangles are named by three angles. Angles can be named in two different ways. So here we have an example of a triangle over here. The triangle is called ABC. All right, it's made up of these lengths, A to B, B to C, and C to A. Now, all of the angles in this triangle can be named in a few different ways. So this angle right here is angle A because it's in the corner that is marked A. Now it can also be labeled as angle CAB. That's just meaning that if you start at C, let's erase this. If we start at C and go in to A and then go out to B, the angle in the middle would be the same as angle A. We can also, to show this angle, label it as BAC, because then you're just going backwards. You're starting at B, going into A, and going down to C. So you still have angle A right here in the middle. So today during your lesson, you could see this angle right here marked as angle A, or angle CAB, or angle BAC. Those are all referring to the same angle. For angle B would be right here, right? You could call it angle B, or you could call it angle ABC, because the B is in the middle. You're starting with A, going into B, going out to C. So your middle letter is your angle. And you could also reverse that and call it angle CAB. That would just mean you're starting at C. Let's come back to this. That would mean you're starting at C, going into B, and going back out at A. No matter how you draw that, you still are showing the same angle. And then for angle C is right here, right? So we could call angle C angle BCA, because it goes from B to C to A, leaving this angle as the one you're talking about. Or you could reverse that. You could reverse that and call it angle ABC. All right, so the sum of all three of your angles in any triangle is going to add up to be 180 degrees. It's going to be very important in this lesson in finding missing angles. Let's make sure you have that in there and that makes sense to you. So sum means adding them up. So if you know some angles in a triangle, you can find missing ones because they should all add up to 180 degrees. And then lastly here, using information about the triangle, you can set up an equation to determine any missing angles, and we'll do that a lot in this lesson today. All right, so we can classify them by their angles. We can also classify triangles by their side lengths. So the side length of a triangle corresponds with the angle measurement of the opposite side. So what that is meaning is that angle or side length AB is going to match up with angle C. So angle C would be this angle right here, and going across from that, straight across, is this side right here. So this side length is going to correspond with the angle across from it. The side length of BC is going to correspond with the angle across from it, so that is angle A. And the side length of CA, the side length of CA right here is going to correspond with the angle across from it. So across from it would be angle B. So what it means by corresponding is that the smallest angle is going to be opposite of the side with the shortest side length. And the largest angle is going to be opposite from the side that's the longest. And a side is congruent, meaning the same size, to another side if it has equal length. All right, triangles can also be classified according to their side length and angle measurement. So here are some different kinds of triangles that we're going to learn about today. First is an equilateral triangle. Now, like the word itself, see how this word has equal in it? Equilateral. That gives you a good clue on what it means. All of the side lengths are going to be equal. An isosceles triangle is going to have two lengths that are the same. Now, the way that I remember this is that you have two eyes. So think of these two side lengths as your eyes. There's your eyes. All right, your isosceles triangle has two eyes or two side lengths that are the same. So even though it's spelled with an I like to think of it as E-Y-E, like the eyes you have on your face. An isosceles triangle has two eyes or two side lengths that are the same. And then a scalene triangle, none of the side lengths are the same. They are all different lengths. One is going to be your shortest, and then this one is going to be your second longest, and then this is your very longest. So they all are different lengths. So remember your three ones. Equilateral, they are all equal. Isosceles, you have two eyes, so two of the side lengths are the same. And then scalene is like a scale. They're all going to weigh different amounts because they're different sizes. All right. Triangles can also be classified based on their angle measurement. So an acute triangle has 3 acute angles. So all of these angles in here are less than 90 degrees. A right triangle has 1 right angle. So right here, see how it makes a perfect square in the corner? That's called a right triangle. And then obtuse is easy given the name. It has 1 obtuse angle. So this angle is more than 90. The other 2 angles will be acute, but if it has 1 obtuse angle, it's called an obtuse triangle. All right, for this section, we're going to use these pictures up above to help us answer these questions. A says, which side corresponds to angle MNO? So let's find angle MNO. You start at M, you go into N, and go out to O. And the angle that that's talking about is the one right here at the center of that. So if we want to know which side length corresponds with that, we have to go straight across from it. So straight across would be this side length right here. And the side length would be labeled MO with a line over it saying that that's a side length. All right, our next one asks us which side corresponds to angle TUS. So TUS is talking about this angle right here. Let's do that different color. Right here. All right, so angle U, in other words. An angle U is across from this side length right here. So that side length is side TS. All right, our next one says, which side corresponds to angle VXW? So VXW would be talking about this angle here, so angle X, and that's across from this side length here. So our side length that corresponds with that would be side length VW. Which angle will be the smallest in triangle PQR? So talking about this triangle right here. PQR, this triangle. Which one is going to be the smallest side length? Well, we need to know the other missing angle right here, because our smallest angle is going to be across from the smallest side length. So remember from a couple of pages ago, we know that every triangle has 180 degrees total. So if it starts with 180, and we already have 41.4 and 77.2, we would add those two together. Oops, 41.4 and 77.2, and we would get, 128.6. I added that wrong. Sorry. That should be 11, not 12. So 113.6. So if we subtract that from the 180, let's see what we're going to get here. We've got 0.4, and then 9 subtract 3 is 6, and then 6. So this angle here is 66.4. So if we're looking for the smallest side length, you look for the smallest angle, which is the 41.4, and go straight across from it. So straight across from 41.4 would be line RQ. Oh, hold on. It didn't ask for side length. It just wanted to know which one was the smallest angle. So the smallest angle would still be found by finding all three and then comparing them. But our angle there is going to be RPQ. So starting at R, starting at R, going into P, going out to Q. Or we could have just said angle P is the smallest. All right. On E, it wants to say which angle is the largest angle in triangle MNO. So MNO is this first triangle here. We've got a 28, let's move that. We've got a 28.7 here. If it has a little square in the corner, that means it's a 90-degree angle. And then we need to figure out our missing angle here. So if the total is going to be 180, we could just subtract the 90 really quickly and say, okay, out of these two angles, we're splitting it up between 90. So 90 subtract 28.7 for that third missing triangle is going to give us, let's see. Oh, I'm running out of room. Okay, so we've got 0.3, then we've got 9 minus 8 is 1, and 8 minus 2 is 6. So this angle here is going to be 61.3. So the 28.7 is obviously smaller than 61.3. So your smallest, oh wait, we're looking for the largest one. Our largest one is going to be the 90 degrees. So that's going to be angle NOM. You could have also noticed that the longest side length in this triangle is right here. And so you'd go across from the longest side length to get the longest angle. All right, on F it says, how can angle MON be classified? So we're talking about our first angle, our first triangle there. So that angle is going to be a right angle, the one that we just labeled, because it's a 90-degree angle. All right, here it wants you to determine the missing angle in the triangles below. So we need to remember our rule here that all triangles have a sum of 180 degrees for their angles. So on number 2, we already have 32 degrees and we already have 81 degrees. We're trying to find this missing value here. So 32 plus 81 gives us 113. And so we need to take this away from 180 to find our missing angle. So we've got 67 degrees for our missing angle here. Now if we added all of those up together, we would get 180, right? Okay, on our next one, we are using the angles they gave us again to find our missing angle, remembering that they all add up to 180. So here, they didn't show you that it was 90 degrees, but they did give you this little square corner. So whenever you see that, you need to label that 90 degrees. So if this is 90, then the other two together should be 90, because 90 and 90 is 180. So you can just skip a part and do 90 minus 45, which is going to give you 45. So these angles have the same measurement, which will always be the case in a 90-degree angle. No, it won't, actually. It will always be the case when you have an isosceles triangle, though, because two of the side lengths are the same. All right, so this is terrible. We're going to cut that part out. Okay, we need to, on number 4, find the measure of HIG. So HIG is right here. Oh, sorry. So we've got 51 and 58 for our first two, giving us 109. And total for all three, it needs to be 180. So we're going to do 180 minus 109. And that is going to give us 71. All right, number 5, triangle JHL has angle HLJ, which measures 65 degrees, and angle LJH, which measures 50 degrees. Draw a sketch of triangle JHL and determine the missing angle measure. So that was really wordy and kind of confusing. Just wants you to draw a triangle and label it JHL. Doesn't really matter the order of those. You just need to make sure that in between H, L, and J, you have 65 degrees. So in other words, angle L is 65 and angle J is 50. And then we need to find our missing angle. So let's erase this other work here. So if we have 65 already and we have 50, that gives us a total of 115. And for the whole triangle, there's going to be 180 degrees. So we're going to subtract the 115 from that to get our missing side. So we've got 65 degrees for X. All right, our last couple here, it says classify these triangles below based on side length and angle measure. Find the missing angle. So first for our side length here, if we look at our side lengths on this first triangle, they have the same marking. Now we use these markings to show that they are the same length. If they all have a 2, that means they're all the same length. So if we're just basing our classification off of side length, we can say that that's an equilateral triangle because all sides are equal. Now if we're going to use that to help us with our angle measurements here, if all side lengths are equal, then we're going to have 180 divided by 3 equal sides gives us 60 for each side. So each one of these angles is going to be 60 degrees. If we classified it by angle, we're going to say that this is an acute triangle because all of these angles have less than 90 degrees, so they're all acute angles. So that's called an acute triangle. And then for X, we already found X. It is 60 degrees. Okay, for number 7, classifying this triangle based off of its side lengths. Well, let's look at this. Might be helpful to find our missing angle first. All right, so we've got 118 plus 34 is going to give us 152. So we take their combined total and subtract it from 180. So that gives us 28 for this missing one. So if all of the angles are different, that means that all of the corresponding sides are also different lengths. So this one's going to be our smallest one. This one is our second smallest one, and this one is our largest one. So they're all different lengths. The triangle with all different side lengths is called a scalene triangle. Remember, putting all of those lengths on the scale, you would get different amounts. If we based this off of the angles, we're going to call this an obtuse triangle because it has one obtuse angle right here and then two acute angles, right? So one obtuse and two acute is called an obtuse triangle. And then our missing angle here was 28 degrees. Okay, and then for number 8, remember if you see this little square in the corner, we know that that's a 90-degree angle. So we want to do 57 plus 90 gives us 147, and we want to subtract that from 180. So we have a 33-degree angle here. And so based on side length, these are all different side lengths, right? So that's called a scalene triangle. Now I knew they were all different because all of the angles were different and they correspond to the angle measurement, right? And then if we base it off of angles, there's one right angle, the 90-degree angle. So we call that a right triangle. And we found our missing value, which was 33 degrees. All right, go ahead and summarize today's lesson and then go do your homework, please.